All right, let's look at this example. Find y prime given that y cubed equals 5x minus 7y. All right, so if we take the derivative of this implicitly, the derivative of y cubed is going to be 3y squared, y prime. Derivative of 5x is 5. And the derivative of 7y squared is going to be 14y to the first power times y prime. So now I've got to solve this for y prime. So I'll collect my y prime terms on one side. Factor out y prime. And then solve. So we get y prime is 5 over 3y squared plus 14y, and that's my derivative. Kind of interesting that it doesn't have any x's in it at all. But that's my derivative. All right, let's look at another example. For some reason, I skipped over example 202. Let's go back and do it. Find y prime given that this equation. Now, I'll tell you what let's do. Let's look at that first. If I graph that out, I graphed it earlier on Desmos, or I put it in earlier. It gives us this. So I'll tell you what let's do. Let's not only graph it, or let's not only find the derivative. Let's when we're done, let's maybe evaluate the slope at a couple of places. But first, let's do the derivative. All right, so derivative of y squared is going to be 2y y prime. Derivative of 2x squared is 4x. Derivative of 3y is minus 3 times the derivative of y, which is just y prime. Now we've got to use the product rule on this. So xy, when we take the derivative, y is the first and x is the second. So we'll do first times derivative of the second plus second times derivative of the first. And derivative of 4 is just 0. So what I need to do is take this and solve it out for y prime. Now I'm going to leave all my y prime terms on this side. I'm going to factor out the y prime. So I'm left with, from here I've got 2y. From here I've got minus 3. From here I've got plus x. Don't need a comma there. And then I'm going to push the other terms to the other side. So this becomes minus 4x. This is minus y. So if I put this together, I get y prime is minus 4x minus y over 2y minus 3 plus x. So that is my derivative y prime. Now, I'll tell you what let's do. Let's pick some points on the graph that are easy to find, and let's find the slope there. Now, just looking at this, let's see. Looking at these points, 1.414 comma 0. Now that 1.414, that's the square root of 2. So that's a somewhat nice point. But 0, 4 up here, that's a really nice point. 0, negative 1. Oh wait, I'm clicking the wrong thing. 0, negative 1, and also negative square root of 2 comma 0. Let's find the slope at one of these, and well, let's find the slope at the point 0, 4. Find the slope of the tangent line at the point 0, 4. All right, well in that case, y prime, I'm going to use this notation, at the point x equals 0, y equals 4, is equal to All right, I'm going to put 0 in for x, so it's going to be here and here. I'm going to put 4 in for y, so here and here. So that's going to give me, on top, I've got -4. And on top, I've got 8 minus 3 is 5. So -4/5. This is just a bit of an add-on to the problem. So tell you what, let's do. Let's find the equation of that line too. It should be fairly easy since the x coordinate 0. So y minus 4 equals -4/5 times x minus 0. Y equals -4/5 x plus 4. That should be my tangent line. So let's graph that and see. So let's see, y equals -4/5 x plus 4. Yeah, sure enough, it's right there. That's the tangent line right at that point. Notice on this problem, we had to specify an x and a y coordinate. When I said this find the slope of the tangent line at the point 0, 4, the reason I have to do that is because if I just said at the point with x equals 0, on this graph, there are 2 points that have an x coordinate of 0. So we have to specify both of them. All right, we've got several more examples to do, but I'm going to stop this video and we'll do the next example on video 3.